Okay, we are going to do our 4.3 lesson. It's actually a lot of the same information in 4.2, but let's do our warm up real quick. The warm up says if this is a parallelogram, it is. They're saying that it is. I worded it a little funny. And angle A is 132 degrees. What is the measure of angle B? And I don't have anything labeled. That's A. That's B. It doesn't really matter what the rest is. But these are consecutive angles. It's one angle right after another. If I work my way around, angle B follows angle A. And consecutive angles are supplementary when it's a parallelogram. So we take the 132 angle plus angle B, which is what we're looking for, and together they equal 180 because they are supplementary. So all we have to do is subtract 132. This is right off the quiz you're going to take shortly. I don't trust myself, but let's go for it. 48 degrees. I can't subtract, you know that, but hopefully I got that right. Okay, I'm pausing for questions. That's silly because it's a recording. The next one says solve for x. Well, this involves the sum of the interior angles of a polygon. So if I add up all these angles, there's a little formula kind of that we know. I take 180 times n minus 2 would get me the sum of all of them. So I'm going to use that to help me out. Again, that's going to get me the sum of all of them. So let's do the sum. Sum means I'm going to add them up. 3x plus another 3x plus an x plus this one's an x minus 2 plus this last angle is x. The only thing missing in this equation that looks really long and complicated, but it's really not, is the n value. The n value is the number of sides, and we have 1, 2, 3, 4. It's a 5-sided polygon called a pentagon. So now it's about simplifying both sides. I have a like term, a like term, like term, like term, and like term. This guy's all by himself over here. That's fine. And then over here we'll distribute. So, oh no, that's silly. Let's do the parentheses first, right? I don't know. I was thinking there's a variable in there. So we have 180 times 3. Let's put all these. We have 6, 7, 8x. And then we have that minus 2. No, I missed an x. 6, 7, 8, 9x. And then minus 2 does not have a like term. 9x minus 2. Let's multiply. I should know this, but I don't trust myself. 540 when I push buttons on my calculator is equal to 9x minus 2. Now that what looked like a pretty complicated problem is quickly, oops, can't talk and do math at the same time, is quickly a simple problem. Add 2, we get 9x, and let's slide up a bit, divide out the 9. Let's put our answer over here. X is all by itself. Let's see if 9 goes into this evenly without using a calculator. Remember, you can add up the digits. 5 plus 4 is 9, plus 2 is 11. And 3 does not go into 11 evenly. So 9 is not going to divide into that. I personally like the fraction as an answer, but if you really want a decimal, we could put it, oops, yep, that's it too. Put it in our calculator and we're going to get 60.2 that goes on forever and ever. Okay, so there's our warm up. I'm going to jump now to the 4.3 checkup. Here we go. I have a lot of papers over here. Here we go. 4.3 checkup. Let's zoom in on one of these. I'm going to do 4 of them. They're all very much alike. I'll do number 2. The directions say find the value of x. That would make this a parallelogram. So we have to use the rules of parallelograms that we know, like opposite sides are equal, opposite angles are equal. A whole lot of rules that we wrote down in our notes the other day. So this one I'm going to use opposite sides because they're giving me, obviously, those are equal. 7 must be equal to this over here. 7 is equal to 1/3 x. And I just have to get rid of that fractional coefficient. To get rid of a fractional coefficient, we could multiply by its reciprocal. 3 over 1 is just plain old 3. So when I multiply by 3, I'm going to get x by itself over here, and 21 is the value of x. So if x was 21, that would prove this is a parallelogram because these two would be equal. And again, this 3 over 1, 1 over 3 becomes a 1 times x. It becomes 3 over 3 times x. 3 over 3 is 1, 1 times x is x. That's number 2. Let's try number 4. Here we have, you can see these opposite angles are equal. We could set these opposite angles equal and solve for x, or we could set this angle plus this angle equal to 180 degrees, because we know in parallelograms that consecutive angles are supplementary. For this one though, I think I'm going to use opposite angles are equal. There are times where we can't use that. We'll see in just a minute. Opposite angles are equal in all parallelograms. So let's get x on one side of the equation. I guess, oops, not a 2. And this is why I don't like to write in pen. Okay, not thinking. 2x minus x. And we have 4 now because that became a 0 or disappeared. And then we'll add 97. And x is 111. So when x is 111, that makes these opposite angles equal. Therefore, it would be a parallelogram. Let's look at 5. I feel like we could do the same thing, but everything is equal. Like this is exactly the same as that, and this is exactly the same as that. Let me show you why. Hold on, I'm going to get a whiteboard. Let me show you why I can't use the same method. Let's use a whiteboard because I don't want it to show up on the worksheet. If I set those equal, let's use the easy one. X plus 20 is equal to x plus 20. It kind of seems like, duh, obviously they're equal, but let's just see if I tried to solve this equation. Let's get x on one side of the equal sign. That becomes a 0. That becomes a 0, and we get 20 is equal to 20. Well, that's true. Gosh darn it, can't see a thing. That is a true statement, but it doesn't help me solve for x. I'm trying to figure out what x is. So like here, we could do this opposite angles are equal because the two expressions were not identical. But in both cases here, these expressions are identical. So if I set them equal, I'm just going to get, yep, 20 is equal to 20. And the other one, I'm going to get negative 98 is equal to negative 98. That's true. But I need to solve for x. I need to know what x could be to make this a parallelogram. Oops, come on. So I'm going to have to use the other method of supplementary angles. Consecutive angles, one right after another, are supplementary when the lines are parallel. Let me separate these two problems. So I'm going to get 3x minus 98 plus the angle next to it, x plus 20. They add up to 180 because they are supplementary when the lines are parallel. Let's combine our like terms. We have like terms here, like terms here. We're going to get 4x minus, it's silly that I can't subtract. I mean, I can, but I mess it up so often that I just don't trust myself. We get negative 78. It's a little embarrassing. Oh well. We can still do high-level math even though we don't trust our silly subtraction brain. Again, I'm going to not trust that. If I took my, oops, I'm adding. That's silly. I'm talking and trying to explain. It's not a good idea. All right, here we go. And it froze. Perfect. Okay, let me deal with that. I got all kind of things happening now. That was my last video. It's going on to YouTube. Let's fix the problem, reopen it, and we're good to go. Unfrozen. Okay, now finish dividing out 4. It can at least reduce by 2. Can 4 go into that? Let's just check. No. I kind of like the fraction just as it is, but I'm going to reduce it at least by 2 because it's not a nice, pretty, neat 2. Just make it quick. 1, oops. Shoot. Okay, pen, darn pen. 129 over 2 is the fraction. If it makes you happy, you could write the decimal, which is 64.5. You don't need both. Okay, don't be afraid if it ends up being a fraction or a decimal. In life, things don't always work out neat and pretty and perfect for us. Let me do number 8, and then I think we'll call it good. Those are really the only 2 types of problems that are going to pop up. You're either going to set opposite angles equal to solve, or you're going to set the 2 angles as supplementary, add them up to equal 180. That's if they're right next to each other. We call that consecutive. Let's see, is there space? Yeah, we're going to do number 8 on the next piece of paper. Fit it. I got this. Number 8, it's getting kind of messy. It's funny that this is being recorded. A lot of people can laugh at me now. That's fine. All right, here we go. I could set these opposite angles equal, which I kind of prefer over the supplementary, only because the supplementary tends to be kind of a longer problem. But if I set these opposite angles equal, we're set. The reason I can do it is because they're not identical. They're not written the same way. They are equal because they're opposite, and that would make it a parallelogram. All right, let's subtract 5x. We got to get the x term on one side of the equation. It's smarter to move the smaller coefficient of x over so you don't have a negative number. But it's fine to have a negative number. It would work. It's just we tend to try to avoid that. Let's move the 23 over. We get 3x is equal to 43. Let's divide. It's not going to divide even. Don't worry. It could be a fraction. In this case, it is. And then you could write the decimal for that if you want, but I think the fraction is just fine. Alrighty? That's it. I mean, 4.3 is an awful lot like 4.2, all about parallelograms and knowing the rules of parallelograms, the properties, the qualities, the characteristics. That's it. Have a wonderful day.